Okay, so I'm going to be using, let's see, I'm going to probably put my webcam somewhere here so you can see it as well. Can I make that bigger? Yes, I can. So I'm gonna be trying to test Zoom for these because it seems like it might be a bit more reliable in terms of the audio. I'd like to know if there's any way that I can kind of monitor the health of the stuff, whether I can see whether my microphone doesn't work or something, because that pretty much sucked basically. And I can annotate as well. So I like these. Turn this on because I can annotate as well everywhere I want. And okay, that's good. So now, I wanted to just quickly do a bit of a commentary on this on the previous video that you have not been able to listen to because basically, yeah, that's it. That's my microphone stopped working, so it's VQLS. I'll keep it short, okay? I'll just keep this commentary short. It's should probably PowerShell or something. PowerShell. So I should probably get the notebook started actually. So is this anyhow going to start, or how is my so how is my internet actually doing? Right away. Here it goes. So workspace, we're going to the workspace, and we're basically going to VQLS, and then Jupyter Notebook. Just to give you an idea of what I did. So I actually kind of copied a bit of the base in here, the baseline. But I was, instead of using that cost function that they use in here, I'm trying to implement that with just the Hammer overlap test. And let me walk you quickly through the implementation. So we've got the first, in the first cell is just the import stuff, and then I kind of created, I copied, that's basically copied from the paper, from the tutorial. So this is the fixed ansatz. Then apply B and apply A1. So the general strategy here is that if you have, so let me see if I can click on draw, and I will just click draw. Okay, exactly. So the general strategy here is that we have A and then we have X, and kind of that's what we want to do, right? So A needs to be decomposed, right? So in this case, the example happens to be A is like Z3 plus, I think, the identity something. So, but it's just the identity, right? So the idea here is to, I got to compute. So in this, we approach variationally. So, and in order to approach this variationally, we need to kind of have those two components separately because they add up. So first we're going to do, first we're just going to do VQLS with this part. We'll call it like A1, and then this part is A2, right? So we'll do those things and then sum them up at the end. So that's the basic idea here. And so that's why you have A1, and then basically the overlap test. Let me just go through the cells and apply them. So the overlap test, if I just no, that's not the overlap test. So the overlap test is here. So the overlap test, if I just test it out quickly, sorry, you can see how this looks like. So it's just these, right? And the idea of the overlap test is that you kind of measure each pair of qubits. So for example, we will start with measuring these and these, right? Because the ones that are connected through this control knot. And so we'll take the probabilities for 0, 0, 0, 1, 1, 0, and 1, 1. And, you know, we will add these, and subtract that. And so the number that we get is basically, that's basically what you want. So you want that to be, you know, so this is 25, and this is 25, and this is 25, and this is 25. Then you're kind of gonna get like 75, right? So you want this to be 0.75. I guess that's what you want this to be, for this to be normalized. And then we will do this for each pair, and at the end we'll just multiply them, right? So the idea is if they're all the same, so they're all 1 times 1 times 1, it's 1. If one of them is like 0, then this is going to kill the whole comparison. And that's the, I think that's the idea. I don't know, we'll see. Let me clear these out. And I think I know one thing that I did do wrong is, so here's the post-processing, and that's what I'm doing. So I'm creating the quantum circuit, I'm appending the different measurements, because I'm gonna do this, there's probably a different and a better way to do that, but I'm basically kind of executing 3 jobs simultaneously, or one after the other, not simultaneously, but like where in each we measure a particular pair. So just to make sure that I implement this post-processing correctly. And then we do these overlaps. So we're doing, you know, we're counting, and if it's 1, 1, then we remove, and then we do this for each, and then at the end we kind of add everything up. Exactly. But here, what I should do is I should actually add one thing, which is I should add that the overlap. So here we kind of got to normalize because we've added this up, and so the overlap is the overlap divided by 100, and I got to do for each overlap, because we want those to be between 0 and 1. Yeah. So that's the idea, and I want to test, and at the end you kind of multiply all of them, and so that's the function that you're trying to minimize. The function you're trying to minimize is this one, the calculate cost function. So we're doing first for A1, then for A2. We're applying the circuit, then we're applying this post processing that I just explained, then we're taking another circuit, but without because here's an identity which we're applying. Remember what I just said. This is. So this is the Z part, and this is the identity part, kind of summed up, make A. And what we want to do is we want to basically, you know, kind of add all those things up and return it. And so the idea is this is supposed to give you, and it's 1 minus these, because we want to minimize it. So this means if they are the same, we want the solution to be the minimal. So we want, you know, to return a 0. So if they are the same, we're going to have a 1 in here. And yes, basically, I might have to normalize that as well. I don't know, but that's the idea, I think, right? And then what I'll still have to do afterwards is how to get the actual X, because this just gives me the configuration of angles. So I'll have to run again through the fixed ansatz. Again, this is cheating, right? So we're basically having so we're using the state vector simulator to take directly basically the state vector, which is going to be like the answer. It's not X, but like X prima, right? Which kind of basically is, according to the tutorial, that's like what you're getting as a solution. And so you kind of have to figure out then the solution after that. And I think we're going to leave this out for now. But let's see what happens, okay? So let's see what happens. I think that could work if I run everything again, just because last time I was getting really big numbers because I was not normalizing. That's my guess. So I'm gonna comment that out, do this and do that and see. Okay, so it's not working. Overlap R1. So what am I doing? Maybe I've used it here. So where is this happening? Oh, here, sorry. Okay, so it's in the 1, 3 exactly. Here we go. Okay, but I'm getting the same numbers. So it's not I think that's not doing what I'm expected to do, because those numbers are too big. I don't know why they're too big, why they're so big. I must be doing something wrong in here, but that's the idea. So that's why I left the video. I'm going to stop here. I'm gonna do another video later on. So I just didn't have much time for these, but I just wanted to kind of add a bit of audio commentary to all these. Just so you don't think like I'm just like coding for an hour and a half and doing nothing. And this could all be done probably way more efficiently, but who knows? Let's see. I hope you like the way this works with Zoom. I kind of like it. I really kind of like it. I like the tools in here, and yeah, let's see how this works. I'll stop recording now. Or I think I can just stop the call and that works, right? So Alt Q. End.